be the future of our planet. The skyscrapers of downtown New York City stand in 80 feet of water. Its famous subway system submerged.
Boston, Philadelphia, Washington, Miami, they would all be underwater.
Melting ice has flooded the oceans. The Arctic ice cap is long gone. Severe weather relentlessly assaults the planet.
Record heat, record droughts, record flooding. This is not a world we want to get into.
Crop failure, mass migration, riots, extinction. Global warming. Two words that often invoke dire predictions of the planet's future. But is this really our destiny?
This is the most serious of environmental problems. It's the one that we need to solve now.
We head to all corners of the globe.
The size of the population has declined. The future doesn't look good.
Speak with leading scientists.
Coral bleaching events are clearly telling us that reefs are in trouble.
And examine the evidence to find out what global warming really means, and if rising temperatures can truly make a difference between the world we know today and a world we may not recognize tomorrow. Years ago, climate scientists were discussing whether the Earth was cooling down or warming up. Now, a vast majority of those scientists believe that global warming is real and it's having a dangerous impact on the planet that we inhabit. What caused those scientists to change their minds? What evidence did they uncover? And what have they determined about the future that you need to know? We start here in the ice fields of Patagonia. Sandwiched in the valleys of the Andes Mountains between Chile and Argentina, the Patagonian ice field is the largest expanse of ice outside of Antarctica and Greenland, covering almost 7,000 square miles and extending all the way to the Pacific Ocean.
When I was here in 1998, this lake was completely full of icebergs. We couldn't get our boat to the ice front, and you can see most of the icebergs now have melted.
Glaciologist Stefan Harrison and his colleagues have studied the ice fields for almost 2 decades. Here, hundreds of glaciers, some more than a half-mile thick, have survived many periods of climate warming since the last ice age ripped the Earth. But in the last 7 years, these glaciers have lost 10% of their mass.
20,000 years ago, this valley was much more covered in ice than it is now. The reason why we think climate change is so significant now, though, it's happening at a historically fast rate.
Rapid melting is not happening just to the glaciers of Patagonia. In the United States, one of the nation's most famous landmarks, northern Montana's Glacier National Park, may soon lose the very thing it was named for. Some of these glaciers are 5,000 to 8,000 years old, yet they're melting so rapidly they could vanish in my lifetime. Once there were more than 150 glaciers here. Today, there are fewer than 40. As these before and after pictures dramatically show, glaciers that took thousands of years to form are disintegrating in only decades. And it's happening from the Andes to Alaska. I've heard a lot of people say, hey, global warming, bring it on. I live up here in northern Montana. I'll be able to swim in this lake in April.
If all it meant was slightly milder winters in the north, you know, probably a lot of people would be for it. But that's not what's at stake. We're talking about remaking the world in very dangerous ways.
At the eastern end of the Antarctic Peninsula, a massive ice shelf juts into the ocean. Known as Larsen B, this plate of ice has been in deep freeze for the past 12,000 years. But in the summer of 2002, something unprecedented happens. Larsen B completely collapses. A chunk the size of Rhode Island falls into the sea. Scientists are stunned. Something unusual is happening to ice all over the world.
Okay, 1, 2, 3.
Nicely done.
The glaciers of Patagonia are literally melting before Harrison's eyes, carving rivers through the ice, cooling into lakes, and tunneling holes that burrow hundreds of feet into the heart of the glacier. Harrison rappels into one of these holes to get a closer look at what's happening inside the ice.
Wow. The color's amazing.
Harrison is not surprised by what he finds. More water.
You know, this looks like a solid world, but in fact, actually, all the ice here is melting. There's water running through the bottoms of these ice caves. You can hear waterfalls in the background. This is basically a watery landscape, and this ice is actually melting very, very rapidly.
To Dr. Harrison, melting ice is the canary in the coal mine, an undeniable sign that global warming is happening now. But ice also tells scientists something else just as crucial, when global warming has occurred in the past. The ice is a logbook of the Earth's climate going back hundreds of thousands of years.
You can see the ice here is absolutely full of bubbles, and the bubbles were formed when the ice was formed. And of course the bubbles contain atmosphere, oxygen and carbon dioxide.
Like Stefan Harrison, Mark Serres studies ice.
Don't you lead the way?
Here at the National Snow and Ice Data Center in Boulder, Colorado, scientists have preserved thousands of ice cores drilled from deep in the glaciers of Antarctica and the world's second largest concentration of ice, Greenland.
These are records of past climate, which in the case of Antarctica extend back more than 600,000 years. So really it's recording 600,000 years of Earth's climate history.
Layer after layer of compacted snow contains ancient dust, debris, gas bubbles, all clues to climate behavior. By analyzing this long timeline of climate history, Serres and others can better understand if today's climate behavior is normal or something very different.
Changes that we've seen in the past decade are much too large, much too pronounced now to be simply explained away as just part of a natural cycle. There's something much more fundamental hitting on the climate system now.
In the last 100 years, the Earth's temperature has climbed 1 degree. Could that single degree impact the climate in such dramatic ways? Climate is far from constant. It operates like a complicated machine with many moving parts. Even a slight change in just one of those parts, temperature, sunlight, ocean circulation, can have a domino effect on all the others. So if the temperature goes up or down, it can ripple through the whole system.
To put it into perspective, the depths of the ice ages were separated from the period today by only a few degrees in the global average temperature.
The ice ages, according to biologist Stephen Bacala, were climate changes brought on by natural cycles. Approximately every 100,000 years, the Earth's orbit becomes slightly more elliptical, taking us further from the sun. When that coincides with other cycles, such as periods when the planet tilts away from the sun, it can cool things down.
those changes trigger a set of mechanisms that cause there to be more or less heat put to different parts of the planet.
It doesn't take much to spawn an ice age, just a small drop in the amount of sunlight reaching the Earth. So had New York City existed 160,000 years ago, it would have been on the edge of an ice pack over a mile high. 30,000 years later, it would have been under 20 feet of water. What we need to know, says Dr. Bacala, is that climate change is not always slow or gradual.
There's a class of almost instantaneous climate change that I call monsters behind the door. I call them monsters because were they to occur today, they would be catastrophic.
Monsters that many scientists fear may be unleashed in the coming decades. January 1, 2006. Across southern Australia, the summer heat blasts its way into the record books. In the capital of Sydney, temperatures top 111 degrees. By the end of January, the most destructive brush fires in 20 years raged throughout the country, killing 9 people. After the hottest year on record, the new year brings only more of the same.
Yeah, I mean, look how hot this is. This is just amazing, isn't it?
It is.
It's hot country.
In New South Wales, Fire Chief Russell Rees inspects the damage left by a wildfire during what should be Australia's wet season. The severity of the devastation is surprising and alarming. After 30 years in the fire service, Rees is fighting an enemy he no longer recognizes.
Bushfires are part of the Australian phenomenon. They've been around for millions of years. What's changing is how the fires behave, the frequency of the fires, and the way that they burn and the things that can change during those fires.
After a decade of drought, these grassy hillsides have become the most combustible kind of fuel, deprived of moisture for years. And there's something else that Rees has noticed, something that tells him a greater force is at work than just simply a dry spell.
It's also changing the short-term weather patterns, giving us this volatility, this spikes in the weather that is causing us to go from calm days to very, very blow-up fire condition days, just out of the blue.
Extreme heat. It's not just happening in Australia.
To the weather now, and no surprise, it is awful.
Chicago, 1995. Temperatures over 100 degrees kill 739 people in only 5 days. And in Europe, 2003, more than 30,000 perish when a record-breaking heat wave grips the continent. Of the 21 hottest years on record, 20 have occurred since 1980. There are some people saying, look, the long history of the planet, it's always had spikes, up and down.
Climate has changed throughout Earth's history for natural reasons. The difference is that in the future, climate change will come on much faster than any change in the history of civilization.
How can experts such as Dr. Michael Oppenheimer be so confident that this current warm-up is unusual? The reason can be found back in the Ice Core Laboratory in Boulder. In layer after layer, going back hundreds of thousands of years, scientists can measure tiny samples of atmospheric gases that have been trapped and preserved. And there's one gas in particular that follows the rise and fall of temperature almost perfectly. When temperatures go up, there is more of it. When temperatures go down, there is less. That gas is carbon dioxide, CO2.
in analysis after analysis, Serres and his team find something alarming.
We find carbon dioxide concentrations in the atmosphere today are higher than anything we've seen in the past 600,000 years. This is telling us that present-day climate is very unusual.
CO2, carbon dioxide, is not pollution. In fact, it's essential to life on Earth as we know it. Animals exhale it, plants and trees breathe it in. And carbon dioxide plays another vital role on this planet.
It's one of the gases in our atmosphere that helps keep the Earth warm. When the sun's energy hits the Earth, some of it is absorbed and some reflected back into space. CO2 traps more of that heat energy and holds it in the atmosphere.
That's the greenhouse effect, and it's a good thing, because without that natural greenhouse effect, Earth would be about 60 degrees Fahrenheit cooler than it is now. It would be a frozen desert, and humanity would never have developed.
All the greenhouse gases together, CO2, methane, water vapor, nitrous oxide, make up only 1% of our atmosphere. Not much. But the climate history has shown how even slight changes in the amount of those gases, particularly carbon dioxide, can swing the Earth's climate from one extreme to another. And as scientists have discovered, never since human beings first walked the Earth have carbon dioxide levels been this high. The question is, why? This is the Amazon. More than 1.5 million square miles of rainforest, roughly the size of the continental United States. It's famous for its striking beauty and the diversity of life that calls the forest home. The Amazon also plays a less obvious, more critical role in the health of the entire planet. The billions of trees here and in forests around the world absorb carbon dioxide on a massive scale, helping to keep levels in check. Without them, a lot more carbon dioxide would remain in the atmosphere. What we need to know, say Amazon researchers, is that the CO2 now flooding into the atmosphere is beginning to overwhelm the Earth's ability to absorb it. To make matters worse, the Amazon is under attack by loggers, farmers, and drought.
We're looking at what could be the future of much of the Amazon. It's a forest that's burned repeatedly, and the trees that are left are extremely tolerant of drought. They can take a lot of drought.
Daniel Nepstead has spent more than 20 years studying how to best conserve the Amazon, often referred to as the lungs of the planet. 2005 was the driest year Nepstead has ever seen. He believes that the climate is changing here, steering rainfall patterns away from the Amazon. When the rain goes away, so does the rainforest.
Right now is probably the worst time of the day for the tree. It's having the hardest time getting water all the way up from the ground, 30 meters below, to this level. It's 100 feet of vertical draw that these leaves have to do.
What Nepstead wanted to learn was how long the trees of the rainforest could survive these droughts. To find the answer, Nepstead didn't climb trees, he dug. What he found surprised him. Instead of a shallow root system, these trees have the capability to extend roots more than 40 feet down in search of water, making them much more resilient to dry conditions than he ever expected. But Nepstead believes these trees have a tipping point.
even that very deep soil will eventually run out of water. If there's not enough rainfall coming into the rainy season to recharge it, to supply water to the trees during the dry season, when there's very little rainfall, then they'll start to die.
Not only will a large-scale loss of these towering trees destroy a unique ecosystem, it will disrupt the forest's ability to absorb carbon dioxide. And in fact, it may do the reverse, release it. When the trees die and decompose, oxygen in the air mixes with all the carbon stored in their tissues. The result? Carbon dioxide released into the atmosphere.
There's 15 years of global emissions of carbon stored in the trees of the Amazon. So if you nudge that a little bit one way or another, it's going to change the composition of the atmosphere. It's going to make the blanket, which is now thin but getting thicker, grow thicker even faster as carbon dioxide builds up.
Ironically, it was forests such as this from Earth's ancient past that scientists believe are behind the rising carbon dioxide levels overloading the system today. Geologist Bob Spicer explores an open coal mine in China, where the steep walls tell the story of an era in Earth's history, when ancient vegetation was trapped and buried, its carbon preserved and transformed into coal over the course of millions of years.
That's quite a nice little leaf. Sort of a messenger from the past.
55 million years ago, this coal mine, like many places in the world at the time, was a broad, flat swamp covered with trees and plants. When those plants died, there wasn't enough oxygen in the swamp for them to decay properly. They simply sank to the bottom as a thick, carbon-rich mass called peat.
And eventually, that peat surface is covered by other sediments. Sediments upon sediments upon sediments. And the increasing pressure, increasing temperature, changes the peat into coal, what we have here today.
Coal is not the only product made from this kind of geological process. Oil and natural gas started off as ancient microscopic marine organisms, also transformed in much the same way. All that carbon buried for so many years ultimately would be discovered by humans. And they would quickly learn that oil, coal, and natural gas make excellent fuels.
But in the process of burning all of those fossil fuels, we're taking that ancient carbon and converting it into carbon dioxide.
As early as 1896, a Swedish scientist named Svante Arrhenius suspected that burning these fuels on such a massive scale might actually change the atmosphere. But it would take another 50 years for the first pieces of evidence to emerge to back up the theory. In 1957, climatologist Charles Keeling set out to measure the natural rise and fall of carbon dioxide levels as vegetation absorbs it during the spring growth and expels it during fall decomposition. He noticed that the natural ups and downs of the carbon cycle weren't following a straight line. They were actually climbing, which meant more and more CO2 was remaining in the atmosphere each year. His graph documenting the CO2 rise became known as the Keeling curve.
The Keeling curve proved that human beings are increasing the levels of carbon dioxide in the atmosphere, and carbon dioxide is a primary global warming gas.
Fossil fuels that took millions of years to form, we are now burning and releasing as carbon dioxide in just a few decades.
And the effects are irreversible because the gases, once they're emitted, stay in the atmosphere for decades, centuries, even millennia. While we sit here, we're breathing some of the CO2 that was emitted by the first Model T, and some of it will still be here 1,000 years from now. That's the way we're building in an irreversible problem.
The global scientific community no longer questions how we got to this point. It worries that we are pushing the climate to the point of no return. Dr. Nick Lund of the Canadian Wildlife Service is on a return trip to the remote Arctic region of Churchill, Manitoba, along Canada's Hudson Bay. Lund has tracked the polar bear population and its movements here over the past 2 decades in the largest and most comprehensive study of the species ever conducted. His team tranquilizes the bears they find and collects data on each one captured. Their updated records go into the database.
The size of the population has declined from about 1,200 back in the 80s to now it's under 950, so a decline of about 22%, and it's directly linked to early breakup of sea ice.
Polar bears rely on sea ice to survive. For a few short months in spring, the bears hunt on the edges of the melting ice, where seals come up for air. For the bears, this is their last chance to feed before the long summer fast. But the ice is now melting earlier in the year and at a faster pace. The bears simply don't have enough time to hunt all the food they need to survive.
We'll rope the cubs up, and then we'll immobilize each cub by hand. A small amount of the same drug that knocked mom out will knock the cubs out. 12.5 pounds for cub 3. The numbers of bears in the Churchill population are falling as a result of reduced cub survival and juvenile survival. We think that some of these bears are starving. We think that mothers may not provide enough milk for their cubs.
Lund has watched the average weight of these bears decrease by some 15% since the 1980s. Within the next 6 years, female bears may not have enough body fat to reproduce. The chances that these triplets will survive to adulthood, let alone make it to next fall, are slim. They're likely to become another statistic in Lund's database of a species on its way to extinction.
It makes me sad to think that I might be the last person working on this population and be known as a polar bear historian.
It wasn't until recently that scientists even worried about Arctic sea ice, which naturally shrinks and expands each year as the seasons change. In 1979, the sea ice covered almost 1.7 billion acres. That's about the size of the United States. But in the last 2 decades alone, the Arctic has lost an area roughly twice the size of Texas. At first, scientists debated the cause, but few linked global warming and mankind's carbon dioxide emissions to that retreat.
We had certainly noticed that the sea ice cover through about the year 2000 had been on a general decline, but it seemed that this could be fairly easily explained by just natural cycles in the climate system. For example, changes in the weather patterns.
Those natural cycles should have cooled the Arctic down by now, but the warming has only accelerated. Climatologists such as Dr. Serez are now convinced that greenhouse gases such as carbon dioxide are behind the sweeping changes that they've seen here. If the melting continues at this rate, by 2060, computer models predict that there will be no sea ice at all during the Arctic summer.
The potential extinction of a species such as the polar bear is just one reason to worry about melting ice. About 10% of the Earth's surface is covered by ice, most of that in the polar regions. But if enough of that ice melts, the seas will rise dramatically, and the results will be calamitous.
Scientists are keeping a watchful eye on the largest concentrations of ice on the planet, Greenland and Antarctica. More than 75% of the Earth's fresh water is locked up in these two places. In the north, the Greenland ice sheet, almost 775,000 square miles in size, has been rapidly shrinking.
The rate of outflow of icebergs from Greenland has doubled and then doubled again over the last 15 years. And if that happens a couple of more times, we may get to a point where the ice sheet really just begins to collapse.
Scientists believe that if the current warming continues, the oceans will rise by as much as 3 feet by the end of the century. The Greenland ice sheet will contribute very little to that increase, but if temperatures hit the 4-degree mark, scientists worry that it will trigger irreversible runaway melting of the ice sheets at both poles.
The Greenland ice cap contains an equivalent of about 23 feet of sea level rise. The West Antarctic ice sheet contains an equivalent of about 20 feet. If we lose a significant part of either of them, coastal civilization as we know it will disappear.
In the coming centuries, New York City could be abandoned, its famous landmarks lost to the sea.
Boston, Philadelphia, Washington, Miami, they would all be underwater. In fact, the entire state of Florida.
This could be the view of Miami, now 50 miles out to sea. Across the Atlantic, the water would reach all the way to central London. It would be the same story for coastal cities all over the world. And low-lying countries such as Bangladesh, with much of its landmass at sea level, would be almost wiped off the map.
How long would that take, that kind of apocalypse of water, if you will?
Well, the temperature change would be this century, and how long would it take the ice sheets to respond? That could be 50 years from now, could be 100 years from now, but it's not 1,000 years from now.
For many who live in the South Pacific, the encroaching sea is already at their doorstep. In February 2006, on the tiny island country of Tuvalu in the South Pacific, residents braced for what may be the highest tide they've ever seen. Predicted to reach 11 feet, the people here could be forced to flee to higher ground until that tide recedes. Tuvalu is no stranger to flooding, plagued by the occasional storm surge and extreme high tides. But this time, things are different. Tuvalu, only 16 feet above sea level at its highest point, is now in danger of becoming a modern-day Atlantis. threatened by the rising ocean around it.
The high tide on Tuesday was very shocking to me to see that the tide was really high compared to the past years.
Until recently, says resident Diana Samey, higher than normal tides appeared regularly, but briefly in January or February. Now, these abnormally high tides are occurring for almost half a year. The flooding is more severe, sustained, and widespread.
Added on to that, it's the erosion. Our islands have been eroded very badly, to the extent that some of our small islets have disappeared and some are on the way to disappear.
Like most residents, Kelia Vave, Tuvalu's senior meteorologist, can only watch helplessly as her country drowns. The islands of the South Pacific are made of porous limestone and coral rock, and high tides actually swell through the ground, flooding Tuvalu from the inside out. To build barrier walls against the ocean would be pointless.
We're so definite that things won't get better. Things are just gonna get worse and worse.
If the oceans continue to rise, many of these small island countries will simply vanish into the sea. Scientists are in a race to figure out how quickly that might happen. Sea level can be a difficult thing to measure, and there are few records before the 20th century to help scientists measure how sea levels have changed in the last few hundred years. One of the oldest tide gauges ever found is on the Australian island of Tasmania, in an unlikely place called the Isle of the Dead.
We have very few long-term records of sea level, so this does fill a much-needed gap in our understanding of sea level rise in this part of the world.
Records from the gauge, carved in this rock, show that since the 1840s, there's been a sea level rise of 6 inches. It's one of the few long-term records that confirms what scientists believe is happening worldwide. In the last 100 years or so, the planet's oceans have risen anywhere from 4 to 10 inches. But the rising water isn't just a result of the tremendous volume of ice melting into the oceans. Scientists are convinced that global warming is raising the temperature of the ocean as well, and that can have a dramatic influence on sea levels.
A side effect of that warmer ocean is the thermal expansion of ocean waters. That thermal expansion is causing the sea level to rise.
When ocean temperatures warm, the water literally expands, taking up more space. This thermal expansion alone may account for more than half of the rise in the sea level in the last century. The projected rise of 3 feet by the end of this century will do more than threaten cities such as New York and London. The beach, the very reason we go to the coast, may disappear before our eyes.
For every foot of vertical sea level rise along the East Coast, a typical beach loses about 100 feet inland due to submersion and erosion.
In the U.S. alone, this erosion could destroy more than a quarter of all structures built within 500 feet of the ocean and wipe out more than half of our coastal wetlands. But it's the rising temperature of the oceans that scientists fear could impact coastal communities the most. Like the air, it has also climbed 1 degree. That may not seem like much, but when the entire ocean gets warmer, the atmosphere reacts, resulting in all kinds of dramatic and dangerous weather around the globe. There's no better example of this often stormy relationship between the ocean and the atmosphere than a phenomenon called El Niño. When conditions are right, a giant stream of warm water floods into the Pacific Ocean. Normally, this superheated water is pushed westward and trapped against the coast of Australia by powerful trade winds. But when those winds let up and change direction, all that warm water barrels eastward. El Niño is an example of how heat stored in the ocean not only causes the water to expand, but how it can turn weather upside down all over the world. It changes rainfall patterns, causes floods in usually dry places and drought in normally rainy locations.
Is El Nino a manifestation of global warming?
We don't know exactly what the effect of global warming on El Nino will be, but one theory has it that it'll essentially turn the Pacific Ocean into a permanent El Nino state, and that would send echoes around the world and give us a quite different climate.
What scientists are sure of is that the tropical oceans are indeed warming and rising worldwide. And the heat stored in those waters provides even more fuel for one of the most devastating forces of nature, a hurricane. The 2005 hurricane season, a year that didn't simply break records, it smashed them. 28 officially designated storms, including the most deadly to hit the U.S. in almost 75 years.
On August 29th, Katrina slams into the coasts of Louisiana, Mississippi, and Alabama. It is the most devastating hurricane to ever hit the Gulf states.
Reaching speeds of 175 miles an hour and ravaging 100 miles of coastline.
Then, on top of the wind and driving rain, more water. Katrina's storm surge is so powerful, it breaks through the levees of New Orleans, the only city in the United States built below sea level.
The barriers that had withstood storm after storm for the last 40 years were no match for Katrina. % of the city floods. More than 1,000 are killed. The sheer destructiveness of the hurricane has become the turning point for many scientists. Although they can't say that one particular hurricane is caused by global warming, many scientists are now making the connections between global warming, rising sea temperatures, and the strength of hurricanes. Greg Holland of the National Center for Atmospheric Research is not surprised by Katrina's ferocity. 2005 also set the record for the warmest temperatures in the Gulf of Mexico, where Katrina spun into a monster.
But it's here in the Gulf of Mexico that they really get going and develop their full destructive power.
As energy from the warm ocean is drawn up into the atmosphere, it condenses into clouds. Winds grow stronger and start to spiral. More air and moisture are drawn upward in the vortex. A self-feeding cycle of frightening power is born.
The really destructive winds in a hurricane extend out for 100 miles or more, and it is so powerful that it could run the entire electric grid of the United States for several weeks.
But like the El Nino phenomenon, it's tough for scientists to separate natural hurricane cycles from the effects of global warming. Right now, it's a hot debate among scientists because we're in a 30-year natural cycle of hurricane hyperactivity. Holland believes it's not the frequency of hurricanes that warmer temperatures are affecting, it's the intensity.
We went back and we got all of the tropical cyclone data for the entire globe going back to 1970. And lo and behold, there was this major increase in Category 4 and 5 hurricanes.
Should the water temperature continue to rise in the next century as predicted, Holland believes that we'll see not only more of the intense storms that defined 2005, they will be worse.
Where a hurricane was a Category 5, maybe we have to invent a Category 6, who knows, to account for the increased intensity.
And it's not just the hurricanes. Scientists say that we can expect severe weather to become the norm rather than the exception.
As rainfall patterns are disrupted, heavy rain will batter some regions. Intense floods will become more frequent, while in other areas, severe rain will give way to severe drought. In northern China, rural villages and farmlands have endured steadily decreasing rainfall over the last 3 decades. And in the last few years, there has been almost no rain at all. Every year, almost 1,000 square miles of farmland in China turns to desert. Since the 1950s, that rate has doubled.
There have been a lot of people who've left the village already. People want to improve their lot and move upwards. They've moved to a better place with water and much better conditions.
For these Chinese villagers, there may be no option but to abandon their farms to the sand. This is a phenomenon happening not just in China, but in regions such as southern Africa and India. Around the world, weather and climate are changing. But long before the evidence of global warming became too obvious to ignore, the first computer climate models foretold the changes that we are seeing today. And the vision of the future is far more alarming. Despite the significant changes that we've seen in our climate over the last few decades, it wasn't until recently that the majority of scientists believed that global warming might be the cause.
If you talked to me 5 years ago, I would have been kind of a fence sitter on this whole idea of greenhouse gases involved in climate change.
We'd been looking at the natural cycles for some years, and I was convinced they were the dominant force.
And so it's taken us about a decade to really put the numbers together.
Skeptics will say we've been through this in the long course of history before. We've had spikes and drops in temperature. Why is this different?
What's different now is that we now understand quite well what caused these changes of the climate.
Scientists understand those changes in large part because of these massive supercomputers crunching away at billions of climate equations.
Climate models essentially have come out of weather forecasting models. They run for much longer periods. They run for hundreds of years rather than days.
Professor Peter Cox heads one of the most comprehensive climate modeling efforts in the world, the Hadley Center for Climate Research in Exeter, England. These models break down the Earth and its atmosphere into grids, taking into account all the variables that influence climate.
They contain clouds, they contain rainfall patterns, they contain winds, and climate models also have to contain slower components like how the vegetation and the soil respond to change and how the oceans change.
If you have any remaining doubts that human activity is behind rising carbon dioxide levels and rising temperatures, take a look at the results of this Hadley Center model. The red line tracks the actual temperature rise over the last 150 years. The green line, Earth's natural climate cycles. Watch how it begins to deviate from temperature. The yellow line, on the other hand, is the contribution of human activity to CO2 levels. It is almost a mirror image of the temperature rise. But with a climate system so complex, predicting what the climate will do in the future, that's no easy task.
It should simulate weather patterns that occur, not the exact details because they're chaotic, and each time you run the model you get a somewhat different answer.
Dr. James Hansen should know. Back in the 1970s, he spent 7 years converting one of NASA's weather forecasting models into the world's first model to track the impact of carbon dioxide on temperature and what it would mean for future climate. The results were not only surprising, they flew in the face of conventional wisdom at the time.
Scientists were still thinking the world was cooling off. It had
There
more
was talk about a new ice age, in fact.
Yeah. Well, that was based on just the observation that the northern hemisphere was getting cooler. But when you looked at the whole globe, what I found was that the cooling really wasn't very much after 1940. It was only about 1/10 of a degree, and it was already starting back up.
Hansen focused his research on data showing that temperatures would continue to climb. By 1981, his models were predicting that global warming would emerge as the driving force behind rising temperatures by the year 2000. And the models in the following years proved just as accurate.
We pointed out that if we follow the kind of business-as-usual scenario that we'd been on, that we would get melting of all of the Arctic sea ice in the 21st century, which we're now in. And it looks like that's what's happening.
Hansen has confidence in his projections of the future because he has tested them against what's happened to climate in the past. When Mount Pinatubo erupted in 1991, Hansen plugged in all the thousands of climate variables that would follow a volcanic eruption. His model not only predicted the temporary drop in the Earth's temperature and subsequent rise, it was accurate within 1/10 of 1 degree. But given how much scientists don't know about the climate, can the models possibly be accurate about the future?
I'm concerned enough about the parts of the problem I know a lot about. What really worries me are the surprises, the things we haven't yet figured out. There are lots of positive feedbacks in the climate system, and as Earth warms, they may kick in to an unexpected degree.
Feedback loops are some of the wild cards of climate modeling. Independent, self-feeding cycles that can amplify the effects of global warming. One example, melting glaciers. As the ice melts, more ground is exposed. That ground absorbs more of the sun that used to be reflected by the ice. As the ground warms up, the ice melts even faster. A new cycle is born. These feedback loops are happening to the ice at the poles as well.
We start to expose dark surfaces, dark ocean. And that dark ocean absorbs so much more of the sun's energy than the white ice did that the Arctic further heats up.
It's also happening in the air. As the temperature rises, so does the concentration of water vapor. The water vapor absorbs more heat, and temperatures rise even further.
That's why the warming over this century is projected to be as large as 4, 5, 6 degrees. Carbon dioxide alone wouldn't do that. It's these feedbacks in the system that amplify the initial warming, and that's why we're concerned. If the effect was only, well, a buildup of carbon dioxide, a modest warming of a degree or two, that wouldn't be a threat of disaster. What is a potential threat of disaster is the result of all these feedbacks.
Today's computer models factor in these feedback loops, making them even more accurate than before.
We have a much better understanding than we did 10 or 20 years ago. And that case can be made, it's ironclad, really.
All over the world, computer models are now saying the same thing. Global warming is real. The planet will continue to warm.
99.9% of scientists say that we basically understand what's going on.
The science is overwhelming.
The science is overwhelming.
On the ground, scientists are now seeing with their own eyes the very changes forecasted by computers.
I was very surprised to see that the models were predicting very dry vegetation replacing on a permanent basis the Amazon rainforest. I think my first response to seeing those maps was one of fear. It's like, good grief, this thing is much bigger than I thought it was.
And Dr. Jim Hansen has yet another prediction, one that could spell disaster for millions of species across the globe.
If you look at the history of the Earth, there have been 5 or 6 mass extinction events. And what were those associated with? Large climate changes.
4 degrees. It may not seem like a significant rise in temperature, but remember, you need only to look at the Earth's past to see what a difference a few degrees can make.
We're taking the warming that occurred as Earth came out of its last great ice age, which was about 5 to 9 degrees Fahrenheit, and we're threatening to telescope it all into a century instead of several thousand years.
Many scientists believe that temperatures are rising so fast, the Earth's climate may reach a threshold, the tipping point, when there will be nothing we can do to undo global warming. If they're right, by the year 2100, within the lifetime of our children or grandchildren, our world will be a drastically different place. Many of the plants and animals so familiar to us now will simply disappear. As spring comes earlier and summer becomes longer and hotter, entire species of trees and plants will die off, unable to adapt to the new climate. Wildlife that can migrate will move to where the climate itself has shifted.
We've now had about 3 decades of rather rapid temperature change, and so the zones have moved about 100 miles. And some species can adapt to that, but that's a very fast rate of change. Some species won't be able to keep up.
In some of the planet's most unique habitats, like the Arctic, there will be few places for the wildlife to go.
The rate at which we're losing sea ice now, polar bears really don't stand much of a chance to be able to evolve back into something else.
Also in danger, one of the Earth's most unique natural wonders, the Great Barrier Reef off the coast of Australia, the largest structure of living organisms on the planet. But the ocean is far too warm for the corals. Unlike birds or other migratory species, coral cannot escape when they're threatened by their environment. Marine biologist Ove Hugh Goldberg checks on the reefs near the Great Keppel Island. He only needs one glance to know that these corals are in trouble.
Wow, this is amazing. Everywhere I look, all I can see is bleached corals. Corals that are normally brown are now glowing a brilliant white.
The reef appears bleached because the algae that normally live with the corals and gives the reef its brilliant color has been driven away by higher temperatures.
The machine I have in my hands here is essentially a plant stress meter. This particular machine can tell the efficiency with which the algae in these bleached corals are processing light. I can put this down here where I've got some zooxanthellae still left, and I press a button, and it tells me that most of the algae that are left in these corals are severely damaged, and they've been damaged by a combination of heat and light.
The algae also provides the corals with critical nourishment. Without the algae, the corals can't survive. Neither can the countless marine species that call these reefs home.
This is the third bleaching event in the last 8 years of the Great Barrier Reef. And as predicted, they're getting more frequent and more severe. And of course, personally, I find that rather frightening.
More frightening still, says climatologist James Hansen, are the results of one of his most recent computer models. He set out to project the impact of the climate change on all of the Earth's plants and animals.
We could lose, by the end of the century, half of the species on the planet. And that's not far-fetched.
But for species that do well in hotter climates, such as insects, populations could increase dramatically. That means the world could see more outbreaks of serious insect-borne diseases, such as West Nile virus, malaria, and yellow fever. Insects, plants, and animals are not the only species that will be on the move. Humans will also struggle to survive in a changing environment.
People today are still strongly dependent on the climate. So that, for instance, in the arid parts of the developing world, there's almost a perfect relationship between how much rainfall occurs and where the people live. And this means that even a small change in the distribution of rainfall, the kind that is inevitable as the climate changes, will cause severe hardship.
Millions may starve to death or be forced to flee to places where there is more food and water, putting a tremendous strain on other countries. War could break out over remaining farmland. Even in the United States, the long, hot summers and extended periods of drought could push America's vast farmlands further northward. Winters may see more precipitation, but they'll be significantly shorter. A reduction of the annual snowfall in mountain ranges such as the Rockies will impact not just the ski season. After all, 75% of the West's fresh water comes from the snowpack. There may not be enough drinking water or irrigation for crops. All over the world, the welfare of millions who depend on glaciers and mountain snow is at risk. Is at a crossroads.
If we decide to burn all the oil, gas, and coal on the planet, we're going to take the atmospheric carbon dioxide concentration we started with and make it 7 times that. And that will create a world that's so very different that I think there's no chance that we'll actually burn all the oil, gas, and coal. I think it's inevitable that we're going to decide to solve this problem. The only question is when.
We may not be able to stop global warming, but we can slow it down and make the changes less extreme.
The good news is the future remains still largely in our hands. There is going to be more warming, but it can be a modest warming, and we can have a soft landing instead of a crash landing.
The 6.5 billion people on our planet have collectively become a force of nature on a collision course with our climate. The question now is, what can be done to correct our course? More than 1 billion people live in China alone. While the CO2 emissions of the average Chinese person are still well below the global average, the country is in the midst of an unprecedented industrial revolution. The Chinese plan to add 1 coal-fired power plant every single week for the next 7 years. One of the biggest investments in infrastructure in the history of the human race. China's CO2 emissions are rising rapidly. It is already the world's 2nd largest source of greenhouse gas emissions. Number 1, the United States. Right now, the U.S. makes up only 5% of the world's population. Yet it is responsible for 25% of the carbon dioxide released into the atmosphere. With the world's 2 most populated countries, China and India, already emerging as energy-consuming industrial giants, scientists such as James Hansen agree that the need for bold, corrective action on a global scale has never been so urgent.
We should have started a decade ago and getting really serious about it, but we'd better start now. The orders of magnitude of this are huge, but I think there will be legal responsibilities, not only because the United States is the biggest producer of greenhouse gases, but because we have discouraged the completion of international accords that would have mitigated the problem.
Hansen is referring in part to one of the most sweeping efforts to date to cut greenhouse gases, a plan known as the Kyoto Protocol. Under this treaty, industrialized countries commit to reduce their emissions by certain amounts and dates. More than 160 nations now have ratified Kyoto. Despite the U.S. role in drafting the 1997 treaty, Congress has rejected Kyoto for the last decade because developing nations are excluded from the agreement. In 2001, the current administration withdrew the U.S. from Kyoto completely, saying that the targets aren't practical, they will hurt the economy, and that much more research is needed to establish a direct link between human activity and greenhouse gases. That decision has been widely criticized by the international community.
Some people say that we should learn everything about the way the climate works before we act to solve global warming. But that's in a way like sitting in the control room of a nuclear reactor and pushing the buttons and hoping that nothing dangerous happens.
Since the Kyoto Protocol was introduced, emissions from the United States have increased more than 6%.
Why do you think there's such a persistent minority of people who just refuse to believe that global warming is a fact?
This is a very big deal. And to some people, I think the very notion that human beings have the capacity to completely change the world is frightening, number one. In addition, there are some people who have a financial interest in not believing.
Still, many countries are taking aggressive steps to cut emissions and moving forward with big ideas to solve the global warming problem. Perhaps one of the most intriguing solutions lies deep beneath the Norwegian Sea. This is the Sleipner natural gas rig. Dr. Pakala believes the wave of the future is here, 100 miles off the coast of Norway.
This is spectacular. I've wanted to come here for a long time now.
Dr. Pakala is here to see a promising technology called carbon sequestering. The idea is to capture all the carbon dioxide this gas rig would normally emit before it is released into the atmosphere, converted into a liquid form, then injected into a huge underground reservoir more than 3,000 feet beneath the seabed.
This is one of the largest objects ever lifted by people, and it's sitting here on the sea floor for the sole purpose of keeping harm out of the atmosphere.
Sleipner is the only place in the world where so much carbon dioxide, almost 3,000 tons a day, is pumped into what amounts to a natural underground storage container. The project is funded by European government and industry. Scientists aren't sure yet if the carbon dioxide will eventually leak from the ground, but if that can be prevented, Pakala believes the Sleipner model could be mass-produced and CO2 levels drastically reduced.
It's going to give us an additional bridge to the future so that we can get to a different sort of an energy system sometime at the end of the century.
Whether it is carbon sequestering in Norway, solar power in the U.S., or wind farms in Great Britain, technology is one solution. Making better use of natural resources is another. Halfway across the world, in South America, Brazil is using its most abundant crop, sugarcane, to produce ethanol. Ethanol, most commonly used as a gasoline additive, reduces the amount of CO2 cars release into the atmosphere. Brazil is now the world's leading producer and exporter of ethanol, and as a result, it has completely weaned itself off of foreign oil. But yet another challenge for Brazilians and the rest of the world lies here, in the Amazon rainforest, which plays a vital role in scrubbing CO2 from the air. More than 5 million acres are lost every year to loggers and farmers in the Amazon.
Countries around the world are starting to realize that if we really want to deal with climate change, we've got to have something to slow the destruction of rainforests as well.
Ecologist Dan Nepstad believes that the future of the Amazon lies in part on an emerging new market called carbon trading. Under the Kyoto Protocol, nations that don't meet their CO2 emissions reduction goals must buy carbon credits from countries that do. That creates incentives to comply with Kyoto and penalties for violating the terms of the agreement. South American nations are proposing that they receive extra carbon credits if they can show they are preventing deforestation and preserving the Amazon's ability to clean CO2 from the air. These countries, and ultimately the Amazon, would profit from selling the credits. Nepstad is hopeful that that would create as much financial incentive to preserve the rainforest as there is to clear it.
There's lots of interest. The mechanism is there, and it could generate 5 times more funds for conservation of the Amazon than currently exists.
But even the most optimistic scientists agree that it will take more than saving the rainforest or injecting carbon dioxide beneath the seafloor to turn back global warming. It will require a new approach to the way we live and work. And of all places, New York City, once a national symbol of environmental neglect, is beginning to reinvent itself as the green apple.
New York City, which is often called the capital of the world. More than 1 million people jammed onto this island, which is just 12 miles long and a few miles wide. And as they operate 24/7, they can do a lot of damage to the environment.
But change is in the air. Today, New York is actually one of the most energy-efficient cities in the U.S. and provides a glimpse of how other cities can work toward a more climate-friendly future. More than 1/4 of carbon dioxide emissions in the U.S. comes from transportation, including cars and trucks. New Yorkers rely on mass transit more than any other city in America. Fewer cars on the road translates to significant cuts in greenhouse gas emissions.
Concerns about the trends in global warming are changing the way that we look at all transportation. Take New York City's iconic yellow cabs. Some of them are now green. They're hybrid vehicles.
The city is beginning to add hybrid taxis, which mix gas and electric power into the fleet. The hybrids get almost double the gas mileage of a conventional cab and send far less CO2 into the air.
They're saving a lot of gas. Second is good for air pollution.
And the city has gone a step further, moving toward a more fuel-efficient public transportation system as well. New York has the largest hybrid electric bus fleet in North America. Even Wall Street executives, accustomed to plush black limousines that serve as mobile offices, are beginning to take part. Ozo Car is the latest in chauffeured services, a private car company offering a guilt-free, door-to-door hybrid ride, complete with laptops and wireless internet access.
You know, they're interested in saving the environment. You know, they like that there's good gas mileage. They're interested in purchasing a car themselves.
But it's more than green machines moving New Yorkers toward climate-friendly living. Ellis Island and the Statue of Liberty now run on electricity generated from wind power.
And throughout Manhattan, green construction is on the rise. That's incorporating energy efficiency into this concrete jungle.
The Hearst Corporation recently finished building its new world headquarters in Midtown Manhattan.
There were a lot of people that told me we couldn't build a green building in New York City.
Ryan Schwagel is director of real estate for Hearst. What began as a move to incorporate a few environmentally friendly ideas into Hearst building plan has evolved into a new standard for green architecture in America. Hearst began by literally recycling the existing building they were gutting before beginning to rebuild on top of it.
We scooped out the materials, and 80% of the old materials were then sent into recyclable areas to be reused in other construction products.
The energy used to make cement, iron, and steel dumps more CO2 into the air than just about any other source in the U.S.
Construction waste is a huge dilemma here in the United States. So when you're able to address that going in, that's the greenest thing that you could do just from the start.
And the recycling didn't stop with the demolition.
This has the look of a shiny new building, but a lot of the material here, I gather, is recycled.
Yes, the steel itself, 80% of it is made of recycled material, and it uses 20% less steel than a normal skyscraper.
There is an environmental purpose to almost everything in this building. A 3-story waterfall humidifies and chills the lobby as the temperatures require. It runs on recycled rainwater collected on the roof. Inside the office space, more recycled materials, from the floor and ceiling tiles to the carpets. Using more recycled material means using less energy that emits more carbon. Office furniture is made from sustainable wood.
What does that mean? That
it means it was forested from places where they're going to try to actually replenish that forest at a later date.
Was that hard to find?
It is very hard to find.
The building uses almost 25% less electricity than other skyscrapers surrounding it, saving altogether more than 1,000 tons of CO2 from being dumped into the air every year.
From start to finish, what was the biggest surprise for you?
The biggest surprise is how you can make green look so beautiful. It really is, it gets that aha feeling the minute that people walk in, and the fact that it has a purpose behind it is only a huge plus.
The Hearst Tower is just one of a number of green skyscrapers being built across New York. From 7 World Trade Center, the first of the skyscrapers destroyed on 9/11 to be rebuilt, to the nearby Solaire, a luxury apartment building. The greening trend in the Big Apple is fueled in part by tax credits from the state. All across the country, cities and states are taking matters into their own hands, whether it's offering tax credits or mandating Kyoto-inspired emission reduction measures of their own.
From an economic point of view, the development of all these technologies could contribute to the economic strength of the country, because this is a whole new area that has not been developed in the past.
It's usually said, well, if we try to address global warming, it's going to cause economic problems. I don't think so. I think it'll create a lot of good jobs, a lot of high-paying jobs.
Big ideas for a big country. But perhaps the smallest actions could lead to the biggest solution. In the 3 million years since humans first walked on Earth, we have been at the mercy of the climate. Now, the future of the Earth's climate is in our hands. If enough people around the world make even a small effort to reduce their energy consumption, we can become a collective force of change.
To get to that solution, are we going to have a more Spartan lifestyle, especially in a place like America, in which we're all very accustomed to our luxuries and efficiencies and ease of life?
I don't think so. I think we can at least start and make a lot of progress on this problem without turning our lifestyle upside down.
So, where do we begin? One of the things that we can do is to take a look at our own carbon footprint, as it's called, to understand just how much CO2 is generated by the average American family.
Girls!
We've recreated a day in the life of one of those families.
What's for breakfast? Yeah.
We'll call them the Smiths. They live in an average American house outside an average American city. The rising blocks represent the Smiths' carbon dioxide emissions, a direct result of their energy consumption. They use an average amount of electric power, which comes to them from an energy grid, powered primarily by fossil fuels, coal, oil, and natural gas.
Bye.
Almost half of the family's annual CO2 emissions, more than 15 tons, comes from their 2 large gas-guzzling cars. What is more surprising, perhaps, is that the energy used in powering the appliances in the Smiths' home puts out almost as much carbon dioxide as driving those 2 cars. Every device used to heat, clean, entertain, or generally make life comfortable produces CO2. Even the food they eat can make a difference. Transporting food, sometimes across continents, racks up another 5 tons of CO2, 10% of the family's total greenhouse gas emissions. Then there are periodic business trips. Mr. Smith's travel alone adds another ton of carbon dioxide.
Well, I hope you guys study for your spelling tests.
Add it all up, and the Smiths produce 50 tons of carbon dioxide every year. There are more than 100 million households across the country, a hefty contribution to the 7 billion tons of CO2 the United States now emits annually.
I think a lot of people understand now that CO2 and fossil fuels are the big villains in all of this, but they wonder what can be done. What are the alternatives? We're going to have to power our automobiles for the foreseeable future, at least.
The good news is that the future, by and large, is in our hands. We are going to have more warming, but it doesn't have to be disastrous. We can slow down the warming and eventually bring it to a halt by measures, many of which are available today.
This is a composite view of the world at night. Imagine how much energy could be saved if we simply turned off lights that aren't being used.
Okay.
Small steps can make a big difference. If every American family switched just one traditional light bulb to a long-lasting, energy-efficient fluorescent bulb, it would be the equivalent of taking 1 million cars off the road.
Ready?
Yep.
Ooh.
Turning the thermostat down 3 degrees in winter and up 3 in summer not only saves the Smiths money, it keeps more than half a ton of carbon dioxide out of the atmosphere.
Emily!
A surprising amount of emissions could be cut if the Smiths were to unplug their television sets, computers, and stereos when they're not in use.
Come on!
These devices consume up to 40% of their full running power when they're in a standby mode, just waiting to be turned on. That could reduce the Smiths' emissions by almost 2 tons a year.
Well, we need tomatoes, don't we?
They can also buy locally grown food, install appliances that get the highest possible electric efficiency, and add insulation to save heat. Even trash contributes to the problem. The truck that carts it away emits CO2, and in the landfill, the garbage itself releases CO2 as it decomposes. But the single most important thing the Smiths can do, use public transportation or change the cars they drive.
We could be driving cars that get higher fuel economy. We don't have to drive cars that get 10, 15, 20 miles per gallon. Let's face it, we're not going to relinquish our dependence on automobiles. They're going to be part of the American culture for a long, long time to come. And that's fine as long as those automobiles are the cleanest, most efficient, least contributing to global warming. And we're failing on that front.
Replacing a gas-guzzling SUV with an electric hybrid car prevents 8 tons of carbon dioxide from entering the atmosphere. Doesn't take much. The average American family can cut their CO2 emissions by some 60% without making any drastic changes in their lifestyle. But even as Americans realize that our behavior is part of the global warming problem, millions and millions of people in the developing world are rapidly becoming carbon copies of us. In China, for instance, a new middle class is emerging, one with an appetite for the same energy-intensive lifestyle that we in the U.S. grew accustomed to decades ago. This couple represents the new upwardly mobile class in China. Call them the Mings. Mr. Ming's new job comes with a new apartment, thoroughly modern even by Western standards. It's outfitted with some of the latest energy-hungry gadgets and appliances. At its current rate, it's estimated that by 2025, China will produce more than 6 billion tons of carbon dioxide annually. That's almost 18% of the CO2 emissions worldwide.
It's a big dilemma for the Chinese leadership. They're trying to build an economy at about 120 miles an hour because they've got billions of people to deal with. And at the same time, the outside world is saying to them, you've got to do it with new technology so you don't make this environmental catastrophe worse.
But China has a problem internally, too, which they know about without us telling them. That's that they have a fearsome air pollution problem, which also comes by and large from their coal burning. And they will get pressure from their own people to a degree that will exceed anything that we exert to change the way that they supply energy and to find ways to burn coal more efficiently and cleaner.
The Chinese and hundreds of millions of others in the developing world are faced with a dilemma. Can they fuel their rapid growth and at the same time contribute to the solution? Unless we reduce emissions and develop new energy alternatives on a global level, the blanket of greenhouse gases that surrounds the planet will double in the next 50 years and triple in the next 100.
We are, in fact, conducting a grand global experiment, and we're going to have to live with the outcome of that experiment.
To have any chance of stemming the catastrophic effects of global warming, most scientists agree that the world must reduce carbon dioxide levels 50% by the year 2050. That seems like a daunting task. But the scientists who see the changes coming, who warn of the dire consequences of ignoring them, are among the most determined and optimistic about the future.
I think that our role is really to err on the side of caution as we look to the stewardship of our planet. We've really got to face it head on.
Most people want this problem solved. They don't want to pass a world on to their children and grandchildren that's headed straight downhill. I'm encouraged. I think we're getting there.
I believe that we have all the technology we need for this generation to solve the problem. What we need to develop is the collective will to implement it.
A will to take on an unprecedented challenge together, to create and embrace new technology, to return to our children and grandchildren the world we inherited.